For the others now. Yeah, there we go. So
Right.
Zachary, give it a read.
That tell me it's a ladder rests against a vertical wall. The bottom of the ladder is being pulled horizontally away from the wall at a rate of d x over dt is equal to 1.5 meter per second.
Wait.
Let x,
Oh, before we finish, Zachary, what does this? What does this mean? Do you understand anything you read over here?
yeah,
So, like, guys, can you imagine that as you pull this thing over here, the rate at which it falls is gonna change. So, like,
yes,
as you pull this, what's gonna happen to this? Like, what's gonna happen to that thing over there?
It will plummet downwards.
Like, yeah.
Yeah, Zachary, could you visualize that?
yes, sir.
Like, let me show you what I'm talking about. Like, watch this. Okay, see what I'm talking about?
Yes,
Yeah,
sir.
sure.
Yeah, look at
Wait, wait, I'm not seeing it. Hold up. Oh, yeah.
Yeah. Oh, basic circuit engineering analysis. I want to teach circuit analysis as engineering stuff.
Oh, nice.
Yeah.
So I just get distracted so easily.
I have ADHD. I have I'll like
Oh,
don't
sorry.
understand. Like I actually have ADHD, you know. I
Hmm.
haven't taken medication since Form 5, but I do. Right. Let me lock
Okay.
back in. Let me lock back in. So everybody understand that as you pull that, it's gonna fall down the wall.
Yeah.
So as you pull this, let's look at the things that are going to change. Well, number one, Zachary, what would change? As it falls, what would change?
Like it would start to drop, so
So what are things that would change?
the height,
The height, yes. So y would change.
yeah,
Yeah. And what about x?
the length of x would change too, so
Yeah, because like okay, if I pull it over here now, wait, like watch this, right? You seeing that?
yes, sir.
That change, you know. So if we're looking at what changes here, then x would change and y would change. Yeah.
Well,
Yes.
so I have a question.
Talk to me.
Would y be like negative because it's a decreasing value, like going down in height, or no?
It
Oh,
would be
yeah?
negative. Yeah, it would be
Okay.
negative.
Thank
So
you, sir.
Zachary, you understand that, right? So like dy dt most likely will be negative because like as you pull it, what happens to the heights? Heights increasing or decreasing?
It decreasing, so it had to be negative.
How to be negative? Now I'm low key giving all the pure math unit 2 questions, you know. I'm low key doing that. low
That's so
key.
fun.
Low key. But I should know how easy these things are.
Yeah.
So Zachary, do you understand that the ladder will always be 10 meters? Right? That changing. That not changing, right? The ladder will always be 10 meters.
Yes, sir.
And as it falls, the height is going to change and the distance from the wall is going to change.
Yes, sir.
So this is telling us that the horizontal distance changes at a rate of 1.5 meters per second. So let me just put some labels, right? So they're saying horizontally away. So x represents what? Horizontal distance or vertical
How far
distance?
is it? So what?
Do you think x represents horizontal distance or vertical distance?
Horizontal distance, sir.
Good. Keep going.
Let x meters be the distance from the bottom of the ladder from the wall, and y meters be the height of the top of the ladder above the ground. When the bottom of the ladder is 6 meters from the wall, find the rate at which the top of the ladder is moving vertically. You may use x squared plus y squared is equal to 100.
Hold on. Whoa, Zach, you probably saying nah. Nah, boy. I can't do this. I can't do this. Probably saying that. Probably saying that. But you could do it. So, you understand that x represents horizontal distance and y represents height.
Yes, sir.
And they're saying when the bottom of the ladder is 6 meters from the wall. So, which parameter are they giving us here? X or y?
X.
Alright, so they're telling us that x is equal to 6 meters. You understand that?
Yes, sir.
Right? And they want me to find the rate at which the top of the ladder is moving vertically. So what do you think they want me to find?
dy over dt.
Job well done. Big up yourself.
Yeah.
Zachary is cooking, guys. Zachary is cooking. Big up
Yes,
Zachary.
sir. Big up, big up.
W.
So Zachary, you can do the same trick you learn the whole when using the whole this topic the whole time. Always
Yes,
you
sir.
multiply to get dy dt.
dy had to go on top there and dt on the bottom.
So tell me, what's the other parameter you have in this question?
dx.
What do we have?
We have dx over dt.
Yeah, we had that. So the only thing we're missing really is what?
dy over dx.
Now, Zachary, everybody in class probably scratching their head and saying, but sir, what the hell is this, boy? I don't understand. Where'd that come from? Where'd that come from? Zachary, you're probably wondering where that come from, ain't?
Yes, sir.
So, for us to handle this question, wouldn't it be convenient if we had an equation that related like the horizontal distance and the vertical distance?
Yes, sir.
Or if I tell you that was it? So let me cook, right? What remains constant here? What remains constant? Like always remains constant in this diagram.
The length of the ladder.
Right. Can everybody agree this is always going to be constant? There's always going to be 10.
Yes, sir.
And do you guys understand? No matter where this thing is, like no matter where this thing is, right? Like no matter where it is, right? It'll always be 10. Like it'll always be 10, right?
Yes, sir.
Yes, sir.
Good. Now here's like the cool thing. You learn this in regular maths.
So I'm thinking of Pythagoras theorem.
Say that again.
Is it Pythagoras theorem?
Bingo. That is it. It's Pythagoras theorem. So, stay with me.
Wait, so I think I forget out though. Is
Talk to me.
6 squared plus 8 squared?
No.
Okay, never mind. Or I lost, never mind.
You have a point, you know. You have a point. But that's correct. You actually figured out something. But I want you to generalize that statement. So no matter where this ladder is, do you understand that it must always be 10?
Yes, sir.
Okay, and what kind of triangle does it form?
What do you mean? What kind of triangle? Like a triangle?
What kind of triangle, guys? What kind of triangle is that?
Right angle.
A right triangle. Oh yeah.
Exactly.
Okay, yeah.
Now, what is the relationship between this length, and this hypotenuse? You were saying it, Jenna, but you just tell me like a specific example. But I want to know the general equation.
Oh, x squared plus y squared equals 10.
You're so close. Remember, Pythagoras theorem is, you can think of it like
10 squared.
Yeah, 10 squared, right? Pythagoras theorem is just like the horizontal squared plus the vertical squared is equal to the hypotenuse squared. You understand?
Yes, sir.
Now, guys, what is 10 squared? Zachary, what is 10 squared?
100.
Now, Zachary, no matter where that ladder is, x squared and y squared will always add up to give you what?
100, because the length of the ladder is the same.
Right, so using that relationship, we actually linking x and y together. So the x squared plus y squared will always be 100. You understand?
Yes, sir.
Cool. So that's the equation. Now, while I was teaching you all, and at the end of class, I was telling you guys, not only time you can make, y the subject of the formula, right? Now,
Yes.
like, if all they wanted, all they could make y the subject of the formula, right? There's no hard feat to do over here. All they could do that. And so they could make y the subject of the formula.
Yes, sir.
Right, but also, if you wanted, you could differentiate implicitly. because y is not the subject of the formula there, and then you're gonna make dy dx subject of the formula.
Oh,
Now,
okay.
I'm going to do it the way you all would do it in hard maths first. Now, before I move on, right, Jenna actually mentioned something important. So, Jenna, x is equal to 6, right?
Yes, sir.
Well, I think we should find for next. What do you think would help us on our journey? We have x.
I was
Fine.
thinking.
Sorry.
Now,
I was
here's
thinking
Zachary.
6 square. Okay.
I want to hear Zachary. Zachary, we have x. We think we should probably find for. Might help us. What might help us?
What do you mean?
So, like, we have x, right? Yeah, we have x. Do you have any idea as to what might help us? Look at the relationship. What's the relationship between the horizontal and the vertical distance? Call out that relationship from again.
It must always be equal to 100.
X squared plus y squared is equal to 100, right?
Yes, sir.
What you have so far? Which variable you have?
We have x.
Which one do you think we should probably find might make your life simple?
For y?
We should maybe find for y.
Yes, sir.
So, how would I find for y? If x is 6.
Say minus x squared from both sides.
Right, so y squared would be equal to 100 minus x squared, and what is x?
X is 6, so x6 squared is 36.
So, Jenna, this is why I say it was cooking, but too soon. 100 minus 36 is 64. Where's the square root of 64?
8.
Aha. Oh, so at this instance in time, Zachary, the horizontal distance is what?
8 centimeters.
Nah, that, remember
Oh,
why?
sorry, meters.
At this point, at this instance in time, the horizontal distance is what? You have it. They told us in the question. They told us in the question. They said it in the question.
All 6, sir.
6 meters. And at this very instance in time, the distance, well, the height, what's the height?
The height is 8 centimeters. X 8 meters, sir.
Good. So this is good information. This is good information. Jenna and Virginia, I'm going to follow the drift so far.
Yes, sir.
That's good. Now, for us to find dy dt, I clearly need to find what? What do I need to find?
dy dx.
Zachary, you see now we don't know what dy dx is. That's like the one sore thing, right? And we don't know what that is.
Yes, sir.
So, like, Zachary, what we had to differentiate?
We got to differentiate in terms of y.
Right, so we could differentiate implicitly. Remember how to differentiate implicitly?
Not really.
Not really. Alright, I will show you. So, what we had to find here again? What we had to find?
dy dx.
We had to find dy dx, right? So we have to find, we have to differentiate with respect to x on both sides. That's what we had to do, Zachary. Because then we want to find dy dx.
Yes, sir.
Now, so Zachary, if I differentiate x squared with respect to x, what would I get?
2.
Ah,
2x, sir.
2x, yeah. By the way, Keshav, I'm teaching them implicit differentiation to handle recent change questions. Yeah. It's a nice question. So yeah. And now, Zachary, we have to differentiate the function y squared with respect to what?
Respect to y.
Yeah, Keshav, I know you could make y the subject of the formula. Like, I know you could just say 100 minus x squared square root, and you use chain rule. I know, but I'll in the class I had earlier tonight, I was showing them implicit, so I just showing them how to do implicit. Yeah. I just remember to do it one time. Right? So yeah. So Zachary, now we have to differentiate y squared with respect to x.
Yes, sir.
So let me explain something, Zachary. What we don't know this, eh? We don't know this. But what if y squared was equal to like 5x or something? What if y squared was 5x? The point I'm trying to make, Zachary, is y squared could be a function in terms of what?
In terms of x?
Exactly. And we're going to treat it as such. We are going to treat it as such. So here's what. We're going to differentiate y squared. Right? Differentiate y squared from here. Like if you, as you would. The point I'm trying to make, Zachary, is y squared could be a function in terms of x. So I want you to differentiate y squared as if you was differentiating with respect to y. So differentiate y squared.
So you get 2y.
You get 2y. dy dx. Because Zachary, here I was saying, y squared could be a function in terms of x. This is actually chain rule I'm doing here. It's always confused people. So like if I differentiate y squared with respect to x, first of all you differentiate y squared. You get 2y. And since you're differentiating that y function with respect to x, you put back on the dy dx. But this is chain rule. That's all I'll tell you for now. Wouldn't want to
yes, sir.
So like, Zachary, let me see if you understand this. If I had to differentiate y cubed, what do you think that would be?
3y, sir.
3y squared.
3y squared, sorry.
And I just differentiated that function, that y function, in terms of what?
In terms of x?
Right, so dy dx. You put on the dy dx. If you do an implicit differentiation, you do that.
Yes, sir.
So like one more. If you had to differentiate 7y squared implicitly with respect to x, what would you get?
So you get 14y?
If you're getting something, remember we differentiate
dy dx.
Right, dy dx. Cool. Right, and if you differentiate 100 with respect to x, what do you get? Come on, Zachary, you got this. 100 is a constant. If you differentiate that constant.
So you get 100 dy dx?
Nah. Zachary, think about it. Does 100 ever change? Like, okay, Zachary, what I'm trying to say is 100 a function to begin with?
No, sir.
So would 100 change depending on what value for x it is? Like, okay.
Nah, sir.
No, so like the rate of changes?
dy dx?
Nah. You're running back again. So we have 100 here. 100 is a constant. If it's a constant, yes, does it accept an input parameter? Like, does it accept an input x?
No, sir.
No, it's just 100. So if x change, would that change?
Nah.
No. So the rate of change is what?
Oh. Not too sure.
All right, Zachary, you can do it. You have this. So let me give you an example, right? Let's just say we had a function, y is equal to 5x. When x is 1, what would y be equal to?
5.
When x is 2, what would y be equal to?
10.
Cool. You understand that? When x is 2, what would y be equal to?
15.
So like, when x changes, doesn't y change?
Yes, sir.
Okay. And the rate of change was 5, right? Because you were seeing 5, 10, 15. Rate of change was 5.
Yeah.
What if I tell you y is equal to 5? When x is 1, what would y be equal to?
Y is still 5.
Okay, what if I tell you x is 2? Is y?
10.
You sure? You seen any x?
Well, I had no x there.
So if it had no x, will that value ever change?
Nah, sir.
So what y go be again?
Y will still be 5.
So the rate of change, so y is changing with respect to x at a rate of what? Is it changing at all?
Nah, sir.
So if it's not changing, what number you would use to describe that? It's not changing.
1
Nah.
or 0?
Zero. It have no rate of change. None. There's no rate of change.
Oh,
None. Like it's not
all
changing
right,
at
sir.
all. So the rate of change is zero.
Okay, sir.
So if I differentiate 100 with respect to x, since it's not a function, it would not
Yep.
change with respect to x. So what would that be?
It will be 0.
That'll be 0. Now guys, this is the part you're gonna like. Right? Didn't we find x and y?
Oh, yes, sir.
Zachary was x. Well, Zachary tell me was x. Zachary was x. What is x? We have it. We know what x is. We were given x in the question as a matter of fact. What is x?
Well, input x into the equation.
Yeah, so like now we could input what x and y is to make dy dx the subject. Because
Yes.
remember, like the whole goal was to find dy dx. That was the whole objective, to find dy dx. So, don't you agree, Zachary? Like if I knew what x and y was, and I could plug it in and make dy dx the subject of the formula.
Yes, sir.
So what's x?
X is 6.
And we're gonna multiply that by y. 2 by y. We're gonna add 2y by that. 2y to that. So what's y?
Y is 8.
Don't tell me d8 and d. Don't do that. No. dy dx is like a figure of speech. It's like telling you that y is changing with respect to x.
Yeah.
Alright, so what's 2 by 6?
12.
2 by 8?
16.
How would you make dy dx the subject of the formula?
Well, 12 plus 16 and then you minus it on both.
Whoa. Gotta take your time. That is 16 dy dx, no? That is 16 by dy
Oh.
dx.
Sorry, well, you minus 12 on both sides.
What next? Very close, Zachary. Very close.
So you divide
I divide both sides by,
16.
and I get minus 12 over 16.
Yes, sir.
Now that make perfect sense, you know. That make perfect sense. Let me explain. So Zachary, when x changes, okay, when the distance from the wall changes, doesn't the height change as well?
Yes, sir.
Do you think why the height increases as the distance increases, or do you think the height decreases as the distance increases?
The height decreases.
Exactly. So this is telling us the rate at which the height changes with respect to the distance from the wall. And since it decreases, it makes sense that it's a what?
That is negative.
Yeah. So that makes sense. So we have
Yes.
dy dx now. We know what that dy dx is minus 12 over 16. So how are we gonna find the answer?
Well, minus 12 over 16 multiplied by 1.5.
What would that be, guys?
So I get minus 9 over 8.
Yeah.
Aha. And by the way, guys, something really cool here. Do you think this would have any dimensions? dy over dx?
No.
No, let me ask Jenna. I'd ask Jenna is the person I'd ask.
Yes.
Jenna is the one, the units. Jenna, where's the unit for y?
Centimeters.
Where's the unit for x?
Centimeters.
Yeah, centimeter over centimeters. What happened?
Centimeters squared. Or just centimeters?
If you had 5 over 5, would you say 5 squared?
Oh no.
What happened? What do you say?
1.
They just cancel off, right?
Yeah. Ew.
So that's dimensionless. That's a ratio,
Okay.
really. That's really a ratio
Okay.
between like the. So like Jenna, you would describe this as a ratio between the change in height and the change in Remember, why is he height? So that's change in height to the change in what? What's x?
The vertical.
Nah. Check it back. What was x? X was the what?
Oh, sorry, the horizontal, the ground.
So this is really a ratio between the vertical height and the horizontal distance.
Okay, yes, sir.
So that's dimensionless. But this, however, would have dimensions. So then I'm not gonna ask you. It's in divided by dt, so what I'll be?
Centimeters per second.
Yes. That's the answer. So does it look like it's gonna move upwards or downwards? Based on the negative sign.
Downwards.
Now that was one way you would do it if you use implicit differentiation. If you differentiate implicitly with respect to x on both sides, that's how it would look like. But, I mean, Zachary, you could do it in a way, you know. So Zachary, if you had to differentiate this, what do you think you would make the subject of the formula? Like, what would you make the subject of the formula?
Why?
Wait, guys, I gotta share this moment. Look at this.
Oh my god, we hit 17K.
Yay!
Yeah, boy. We do it, guys, we do it.
Yes, sir.
We do it. 20K before the mountain. 20.
For sure.
Zachary, put me in that song or something you're making now, boy.
Yeah, come on, then.
I mean, like.
Yeah, I'd say, yeah.
Give us a quick one.
Yeah. So Zachary, if you had to differentiate that, forget about the implicit differentiation and thing. What would you do? Like, if I tell you to find dy dx, like, what would you do? Don't tell me you'll cry, yeah?
Say, can you repeat?
Zachary, if you had to differentiate that and you didn't know implicit differentiation, what's the first thing you would do before you differentiate it with respect to x?
So I would minus y on both sides.
Nah. Here, let me give you an example, right? Zachary, so like, let's look at the alternative solution, right? This is the alternative solution.
Yes.
I think this is the solution that you guys would have gravitated towards instead, right? Now, again, let's pull out the key information. So Zachary, I mean, they told us that dx dt was what? Dx dt was 1.5 meters per second, right?
Yes.
Wait, Jenna, where did centimeters come out from? Jenna.
I'm sorry, I didn't see the question.
That's okay.
Oh, my fault.
Jenna, say that so, like, I feel bad. Jenna, like, when your parents, like, you have an argument, do you, like, give them the puppy eyes?
Nah. It depends, but not really.
Okay. I feel like Jenna is the kind of person to pull that move. Is like
with friends, yeah. Yeah, with friends, yeah.
I see.
Yeah.
So Zachary, they told us dxdt was that, and they told us that x was equal to what?
6 meters.
Right, and they want me to find what again? What they want me to find in this what do they want us to find? What was the question? What do they want us to find?
dy dx.
Yeah, they wanted me to find dy dx. You sure? Read this for me.
Find the rate at which the top of the ladder is moving vertically.
What is that?
Oh, dy dt?
Yeah, we gotta find dy dt, right? So quick with it. To find dy dt, we know it will be dy dx. Multiply by dx dt, yeah?
Yes, sir.
Now, to find dy dx, we gotta differentiate the equation they gave us. So they gave us x squared plus y squared is equal to 100, did they not?
Yes, sir.
Alright, bet. Now Zachary, before we differentiate that, I have a question. If I tell you to differentiate y is equal to 5x, how are we going to do that?
So y is equal to 5.
You mean dy dx is equal to 5?
Well, yeah.
Okay, what if I give you something like 0 is equal to minus y plus 5x? What's the first thing you would do with that before you differentiate?
Add y on both sides.
So you would make y the what?
Subject.
Okay. So before you differentiate this, to find dy dx, what do you think you should do? Most actually lucky and you could do this.
So you minus y.
Let me take it back again.
Gosh.
So before you differentiate y with respect to x, what would you make the subject of the formula there?
You would make y the subject of the formula.
Yeah. So before you differentiate this, what would you make the subject of the formula?
Or you would make y the subject of the formula.
Yeah. How would you do that?
Or, okay, so you would minus x squared on both sides.
Right. So y squared would be equal to 100 minus x squared.
Minus x squared.
What are you going to do next?
So you would square root.
Yeah, you would square root. Now I got to write as a power one time, right? So that will be 100 minus x squared to what power?
To the power of a half.
Yeah, because square root is the same thing as what, Jenna? Square root is the same thing as what?
1/2.
Yeah, 1/2. By the way, guys, random question. Until you see the tanty, she pose like this and she here pathway like one side and how she pose. You know what I'm talking about?
I'm not so sure.
No.
I don't know.
She was kind of like this.
I don't think I know.
Hey boy. Yeah.
You'll have to like show us whenever we find it.
Alright, I'll do that. Look, Mrs. Math Vibes in the comment section saying Rajiv. Nah, I want to say.
So
Yeah, Jenna.
sorry. Quick question. They say that x equals 6 centimeters, right?
Mhm.
But what if we substitute that
Nah,
into?
nah, I can't do
Okay, sorry.
that.
Because that's what I did to get the thingy with the Pythagoras theorem.
Well, if you did do that, you would get 8, right?
Yeah.
But Jenna, this is the alternative solution. So here I
Oh.
say we had to find what? We had to find
dy over dt.
right.
Oh,
but to find
dy
out-
dx.
Okay.
Yeah.
If I give you a question like y is equal to 5x and take a differentiate that easily,
Yes, sir.
what the answer will be?
dy over dx equals 5.
If I give you something like 0 is equal to minus y plus 5x, what would you do before you differentiate that?
I would make y the subject.
Right. Because you would want to differentiate it explicitly. Whenever the function you're trying to differentiate is a subject of the formula, it's in an explicit form. So like this would be in an explicit form, right?
Yes, sir.
This would be in an implicit form because you know y is only subject of the formula.
Oh,
Right?
because you have to make it into something that could be differentiated.
But I mean you could differentiate if you know y is only subject of the formula.
Yeah.
Right? Like let me show you. Well, I mean trust me, it could. Like if you had tan inverse x squared y is equal to 3x plus 6y,
That's
Jenna,
not.
you can't really make y the subject of the formula there.
Yeah.
So all you could do is differentiate implicitly, pull out the dy dx, but you'll notice in dy dx you'll have x and y in it.
Yes, sir.
Yeah.
Okay, I understand.
But like what I'm saying is, in this question, right? Is it possible to make y the subject of the formula?
Yes, sir.
Run me back through the steps that Zachary just took. How did we make y the subject of the formula?
Yeah, minus y squared on both sides.
But we want to make y the subject of the formula though. Why would
Wait.
we minus y squared on both sides?
You move the x squared to the other side, so y squared equals 100 minus x squared.
Right? What would I do next if I want to isolate y?
Square root it.
I would square root both sides, and so y would be
Both
equal to
sides. Y is equal to 100 minus x squared. Sorry, minus x squared.
no minus x squared, and this
Oh.
whole thing would be square rooted. This whole thing would be square rooted.
Okay.
Now, if I square root that whole thing, that's equivalent to raising that whole thing to what power?
To the power of a half.
To the power of a half, yeah. So guys, square root is the same thing to the power of a half. Now,
Okay.
is y, did we make y the subject of the formula there?
Yes, sir.
Yeah, we did. We did. So now we could easily find dy. I wouldn't say easily, but I still think we could easily do it. What rule would I use there, guys? What rule would I use there? You see now 100 minus x squared to the power
Chain
of a
rule,
half.
chain rule.
Chain rule, because
Jenna, nah. Check Jenna. Ooh, Jenna, real improvement, boy. Jenna, remember the first time? You tell him I like you used to feel hard maths and something, but
Yeah.
I think this like I come around. You know?
Yes, sir. Yes, sir.
I think this is like
I'm
a
trying
universal
here. I'm
option.
trying.
It's like
We
a
want that one in NC6. Trust.
yeah,
Trust.
that one in the hard maths.
Yeah.
Alright, Zachary, did you see you had to use chain rule there? Because it's still like a weird power.
Yes, sir.
Yeah? You sure?
Well, yes, I know we had to use the chain rule.
Alright, Zachary, you wanted to use the long chain rule or the shorthand version of the chain rule?
The shorthand version, sir.
You remember the shorthand version of the chain rule?
So that's dy over du multiplied by du over dx.
Yeah, but it's like a shortcut. Anytime you have something like that. I'm gonna take it back to the good old days when we was doing it.
Alright, sir.
You know that song? Take me back to... You know that song I'm talking about?
Yes, sir. I think so. Yeah.
Don't
Yeah.
worry.
Yeah. Yes, sir.
But like the shorthand version is just giving me so many problems. I don't know why.
Yeah, I still prefer the original version.
Yeah.
Yeah.
Seriously, guys?
It's like it's kind of easy.
Yeah.
Well, it's easier because like, we understand it. I think. But
Mhm. So could you explain the shorthand method again? I keep forgetting. I don't know.
Sure. So we use the chain rule anytime we have a composite function, right?
Yes, sir.
So like in all of these instances, you can think of it like there's a function within a function. Hold my hand
Yeah.
while we explain. So like, let's just say you had y is equal to 7 plus x to the power 9,
Yes, sir.
right?
Yeah.
If you were to think about what causing you trouble there, like what do you think is causing you trouble there?
The 7 plus x.
Exactly, because I mean, if it was just x to the power 9, and you could differentiate that.
Yes, sir.
So we could actually argue that there's a function, like there's a function here, like 7 plus x is actually a function, I mean, call that u. So you can say let u be equal to 7 plus x. And
Yes,
so
sir.
y would be equal to u to the power 9. If I say that y is equal to u to the power 9 and I say u is equal to 7 plus x, I need to get back dy dx. So I'm going to find those rates of change, and then I'm going to use the chain rule to multiply to get back the original thing. So this is how you would typically do chain rule. So let's do it back again quickly, and then I'll just show you the shortcut. Zachary, how will you do this?
So well, you will let
Actually,
you.
Zachary, let me just do really hard example and done. Let me just do really hard example and done.
Alright, sir.
Just do really hard example and done. Alright? That's the better thing to do. So Zachary, what do you feel causing a real problem here?
The 100 minus x squared.
So you could just say, let u. But guys, I'm just showing you the shortcut. Like I just showed you the shortcut before we do the long thing. Like it really easy.
Yeah.
Like it really simple.
Okay. I just have problems remembering it, and I don't know why.
So you're gonna pre-multiply by the power. What's the power?
Uh-huh.
Gonna multiply by half. Then you're gonna differentiate the inner function. What's the inner function?
100 minus x squared, so that'll be like 2x.
Whoa, take it
Wait,
back.
minus 2x.
Zachary, differentiate the inside for me. Let me see if Zachary know.
Oh, sorry.
Zachary, differentiate the inside. It was correct, Virginia. I just want to see Zachary if you know it.
Oh, okay. Sorry.
Yeah,
Well, yeah, so
exactly.
it would be minus 2x because 100, you just take that out, yeah.
Yeah, we learn this lesson, right? If you differentiate a constant, it's just zero. So we're
Yes,
gonna get minus 2x. And then we're gonna write back the inner function, and we're gonna do what with the power?
Subtract 1
Right, where's a half minus 1?
minus a half.
That's it. That's it.
Oh,
That is it. Again. And then have like this sound, this like TikTok. Someone would be like, again, again.
yeah.
Okay, so Zachary, walk me through the process again. Quick.
so you would differentiate in the brackets and you would get minus 2x.
Forgetting something. What we gotta do with that power? What do you gotta do with that power?
You multiply by the power, so
Right, so you always multiply by the power first.
yes, sir.
So you pre-multiply by the power, so a half. What do we do next?
Then you differentiate one in the brackets.
Right? The proper
So
way to say
you,
that is differentiate the inner function. So you differentiate the inner function.
yes, sir.
If you differentiate the inner function, what would you get?
Minus 2x.
Then you're right back. Right, so you write back the function that was there, right? So
Yes,
100
sir.
minus x squared. And you do what with the power?
You minus
So like where's a half minus 1?
minus negative half.
That's it.
Yes, sir.
That's it, guys. Jenna,
Okay.
let me see if you remember. So Jenna, we're gonna do the power.
Yeah, put it there, so a half.
Call that pre-multiplying.
Mm.
Then you're gonna differentiate the inner function, and that's gonna become the outer function. So if you differentiate 100 minus x squared, actually, why am I talking? Why am I talking? You tell me to do it. You tell me the steps for everything. I'm gonna stay quiet. I'm gonna stay quiet.
Okay. So you put a half there.
So no, what's it? You pre-multiply.
Pre-multiply, sorry.
Pre-multiply by the
Pre-multiply
power.
by power.
Mm-hmm.
And so that'll be a half.
Mm-hmm.
And then you differentiate the inside the brackets, and that will become the outside
Right.
brackets.
If you wanna be
Um,
real spot on, you differentiate in the inner function,
okay.
and that goes on the outside. So like, what would that be?
That will be negative 2x.
Mm-hmm. What
Um,
next?
now we write the inner function, which is 100 minus x squared, and then minus 1 from the power,
What's a half
which would
minus
give
1?
you negative a half.
Negative half, yeah. And a half of negative 2x is just negative x, so you end up with negative x by 100 minus x squared to the power negative a half. No, guys, Zachary, what did it tell us x was?
They say x was 6.
Exactly, so I could replace x with what?
6
Yeah, so I could say minus 6 by, open bracket, 100, what? Minus what?
minus 6 squared.
Plug that into your calculator, and you should get the correct answer. Why would they even ask this? Why would they even ask this? Look at this. Look at what's on my computer screen. It says, choose your preferred style of key titles, Sharp style or Casio style. Why
The
is that
answer
even
is
a
very
question?
obvious. Come on.
Why is that even a question? Zachary, why is that even a question?
So I don't know, sir.
That's crazy. That is crazy. That's illegal. That's not legal. So that's going to be minus 6, open brackets, 100 minus 6 squared, close the bracket, to the power negative a half. Let me know if you guys getting that.
Yes, sir.
Yes, sir.
Yes, sir.
Wait, let me just check something. Yeah, you guys are going good. So that was equal to negative 0.5, right? Negative 0.75.
Yes, sir.
Again, Zachary, would this have any dimensions? dy dx, would that have any dimension?
No, sir.
Nah, because both y and x have the same dimension.
Yes, sir, they will cancel off.
It's a cancel off. So we have dy dx. What do you want to do next?
So you multiply it.
And the xdt was 1.5. What would we get?
Minus 9/8.
Look at that. Let's go. Which is just minus 9/8. You guys understand?
Yes, sir. We vibing.
Yes, sir.
Bad. And the units for this could be what, Jenna? Jenna, where's the units? Jenna, where's the units?
Centimeters.
Whoa. Oh, we talk about
Wait.
that. Talk about that.
Is it meters? Any question? Meters, right?
And I way to think logically too, eh? If we didn't with our ladder, what ladder would be in centimeters?
Okay, so
No, you understand? You understand what
you
I'm
need to bully me, okay?
I'm not bullying you, no. I just say I would never bully
Yeah.
my students. I just say no. Right?
So yeah, meters per second.
Yeah, meters per second. So we guys rather do implicit differentiation or just make y the subject of the formula and differentiate?
I mean, I've been enjoying the implicit version.
Okay.
I rather make y the subject.
Yeah, I'd rather make y the subject as well,
Okay.
honestly.
No problem. Yeah. But like,
But I mean,
like,
I like the other way as well, but the implicit one. But
when you reach like this level, you can't do that.
Oh,
You can't do that.
Sigh.
You can't make y the subject. You have to implicitly differentiate. Yeah. I'm telling you guys, Pure Maths was such a fun time. Like I really enjoy Unit 2 Pure Maths. So fun, but everybody is different.
So you just love maths too much, sir.
Maybe. Ladies, I had to find a guy like me, you know, that would do maths as opposed to like talk to other women. Yeah.
I see.
Yeah.
Clock it.
As opposed to wait. Clock it with the Casio.
Yes.
Casio what?
Yes.
Bad. Yeah.
Yes, sir. Badness.
Okay. So we done. Although we should be real good with rate of change now. I don't anticipate anybody having any problems.
Yeah, for
I
sure.
don't think so.
So like because like this is way beyond like CXC pay grade. Like if this come, it should be fine. You know what?
So
Doug?
now you're making me kind of confident now.
That's
Thinking
good.
that the questions above is what's gonna come for C6.
Yeah, like this is not gonna come. Let me show you what's
I
gonna
thought this was gonna come in.
come. Like
So
bro,
that come in? Those
this
more questions?
like this will come.
That? Okay.
Okay, let me go in the CXC past papers book I make, and I'll show you a question that came.
Okay, because you have me thinking these long ones gonna come, so I'm like locking in,
In my
Yeah,
head,
trying to like understand.
in my head is like if I scare you guys begin like enough, eventually nothing will scare you all.
So basically PTSD.
Yeah, it's like like you'll ever lift weights and it's like, oh, my phone like real light.
Yes.
Yes.
Yeah, that same concept. Like let me show you guys how easy, right? Let me show you guys how easy the questions in CXC are. They're really simple,
That's coming.
Yeah, this is coming.
Bomboras.
Yeah, I was showing you guys keep level questions. I was showing you guys keep level
Oh,
questions.
okay.
Easy.
I'm feeling smart now.
Yeah, for sure. I'm
Yeah,
feeling very.
yeah.
So I know for trying to do maths and keep, so
Why? Like it actually is so fun.
Nah, I know for sure I will do it because of this. It was fun.
Actually, nah, it is fun. It's fun.
Saga the
Jonathan,
data sciences.
Jonathan, everybody does things differently, but it is mathematically correct. But I see what you're saying. That's correct, right? And by the way, guys, you'll understand the full version of this, right? Like if you were to, you know, with the substitution and you apply the chain rule, let me know.
Yes, sir.
Yes, sir.
Yes, sir.
But I have a question.
Talk to me.
For like the entire rates of change, have you been doing chain rule? Because it looks just like it.
We've been doing chain rule, whole thing was chain
Oh
rule.
wow. Okay,
Everything was
okay,
chain rule.
okay.
Yeah. Actually, the whole foundation of implicit differentiation is chain rule. Like,
Oh,
I want to do a live showing you guys at a time. Like, I showed you all how to do it using implicit differentiation, but I didn't really explain how implicit differentiation works. But implicit differentiation is just it's just chain rule. Chain rule is
Okay.
everywhere.
So I have another question.
Talk to me.
You remember those homework questions I gave us the other day for differentiation?
Yeah.
Would you be able to do another live with those, correcting those?
Yeah, there's no problem.
Please. Because I think now I understand what's a change, but like those kind of a little shaky still.
No problem. Oh, okay, Jonathan, I see. Yeah. Alright, so part C. The length of the side of a square is increasing at a rate of 4 centimeters per second. Find the rate of increase of the area when the length is. Guys, this is not so easy. Jenna, cook. I'm gonna get the floor to cook. Alright? Talk to me.
Okay.
Talk to me. We're going on
So-
next question.
They said the length of the side of a square is increasing at a rate of 4 centimeters per second.
Mhm.
So that would be, so they say rate, so dl over dt
Yeah, so dl over dt is equal to what?
to 4 centimeters per second. And they want us to find the rate of increase of the area when the length of the side is 5 centimeters. So the length is 5 centimeters, and they want us to find dA over dr.
Take your time.
Wait. dA over dr. Yeah.
Nah.
Oh, dt, sorry. I keep saying r and, yeah, my bad.
Anytime you see rate, like rates,
Yeah, it's
rates are
time.
with respect to time.
Yeah.
They way to find dA dt, so what are you gonna do?
So we'll have dt on the top and,
What?
sorry, dA on the top and dt on the bottom. And, well, dl, because that's the only other, yeah. And so they say, so dl over dt is 4 centimeters, but we need to find dA over dl.
Mm-hmm.
So we have to differentiate. Well,
Hey, it's very simple. I swear you not. It's so simple. Don't get scared. Don't get stumped. Go read through the question. Figure out what you're doing. Figure out what DADL is. Okay, say what DADL means to me in English.
the length with respect to the area.
Nah, you say it in reverse.
Oh, the area with respect to the length.
Right. So the change in area with
The
respect to
change,
length.
yeah,
Right.
the change in area with respect to the length.
What kind of shape you was dealing with?
A square.
Could you think of a formula that's,
Oh, side by side, or side squared.
right? Yeah. But instead of a side, what did you decide to call that?
Length.
So, talk to me. What formula you think you should use?
So 5 squared.
Say that again?
5 squared.
Nah. I remember, you can't just plug it in like that. They want us to find the rate of increase of the area when the length is 5. So you have to differentiate first and then input 5.
Also
So, like-
differentiate s squared or l squared.
Yeah. So what's the formula you're going to use to differentiate area with respect to length?
L by L.
But was it, like, say the full thing for me? Like, is the formula for area? Is it?
Oh,
like
A
perimeter?
equals L squared.
A is equal to L squared.
Yeah.
What will the,
So
what will the
then
next line be?
dA over dL
dA over
is
dl.
is equal to 2L.
Right, dA over dl is 12.
Oh. Okay.
And
Yeah.
if we should do next.
Then dA over dt is equal to 2L multiplied by 4. And they say, and we said,
Yeah, by 4, yeah.
and they said the length of the side is 5, so you substitute that into L, so that's 2 by 5 multiplied by 4, which is 10 by 4, which is 40 centimeters per second.
Whoa.
Centimeters squared
Right,
per
right.
second.
Good, that's it.
And that's the answer? Oh. Okay.
I prepare only for like.
So
like,
that's the hardest, oh god. Like for CSEC.
It really
level.
get much harder on this, like, unless you're writing a paper 3. Unless you're writing a paper 3. The rate of change questions in paper 3s are like okay, paper 3 odd math questions are like brutal. They're brutal.
Oh.
They're like this level. They're like this level.
But
Oh.
will we be getting like paper 3 or is that next year exams?
That's in 2028.
Okay, so we can still do our SBA.
Yeah.
Okay.
Oh yeah, I started my SBA. So do you also help with SBA?
If you need help, sure.
Okay.
Oh,
Good.
nice.
Yeah. I have this one, Jonathan. I have this one like. Okay, I do odd math paper 3 prep. And ladies and well Zachary, I have this really nice odd math paper 3 question. Where is it? Oh. Here it is. I honestly like it's muscle memory. It's like muscle memory. It's like muscle memory.
Whoa.
Guys, can I just point out something real quick? This is what I mean when I say flow state with Sue. Because when we start and he gonna finish
Oh,
a certain
God.
time and he
Yeah.
doesn't finish and we just keep going because of the flow states.
Yeah.
Yeah. Is it flow state? Right. All right. So yeah, in B. So like this is on the harder side. This is on the harder side. Oh, Jonathan, I said in 2028 it's gonna be paper 3. 2028, not 2027. Yeah, so you could use your SBA in 2027. Right? I think you misheard what I said. I said 2028 is when they're gonna end the SBA. Well, for non-practical subjects. Right? Okay. So, who wants to help me with this question?
Okay, so I'll volunteer.
You're gonna volunteer?
Yeah, sure.
It's easier than you think. Like, all these questions are easier than you think. Fun questions.
Okay.
I see
Okay.
Bali say the answer is 3. Bali, you want to come join the Zoom and do some advanced more?
Yeah.
Allow Mr. Bali to come do advanced?
Yes. Yes, please.
Alright. Okay. We'll await his response.
Okay.
Okay. So, well, like, you'll see how simple these questions are, right? Like, these questions are really simple. Like, the ones you'll get at least.
Yeah.
Yeah.
And like Jenna, you see in this question where you were having a hard time, like, okay, you saw, like, they didn't give you the formula, right? They didn't give you the formula.
Yes, sir.
But you saw
But it
that
was right there.
they said it was a square, right?
Yeah.
They said it was a square and it was the ADL. So you had to figure out, like, you had to get the area formula for a square. You understand?
Yes, sir.
Alright. Cool. So Virginia, get this question and read for me.
Okay. The cuboid shown in figure 2 has a width of x meters and its length is twice its width. The volume of the cuboid is 720 meters cubed. So one final expression for the height h of the cuboid in terms of x.
Right.
2.
So-
show that the expression for the surface area A of the cuboid is given by A is equal to 2,160 over x plus 4 x squared or cubed?
That's squared.
Okay, for x squared. And 3, hence show that a has a stationary value when x is 3 by the cube root of 10.
Yeah, so these are the type of questions you could expect in an odd math paper 3.
Okay.
Yeah.
I'm shaking in my boots right now, but okay.
No, it'll be fine.
Okay.
I feel like it's going to be the last question I'll do for tonight. Last question.
All right, I understand.
So, I mean it, guys. I mean it, like, I mean it.
Okay.
Right?
Sure.
If I let Seema, or later Josh, if I let Seema go to do another question, I'll let her know, like, I'll let her, like,
Okay.
Yes,
Alright.
sir.
The cuboid shown in figure 2 has width x, and they say that its length is twice its width. So what does that mean?
Okay. So, like, width is x and length is 2x.
Mm-hmm.
Wait, what else? Is there something else I'm supposed to see? No?
Not really.
Okay.
So like, what do you think what would happen? So like, let's try to answer part 1.
Okay.
So part 1 says find an expression for the height of the cuboid in terms of x. So do you agree that this will be the height,
Yes, sir.
and this will be what
The length.
exactly?
Mm-hmm.
Right.
So the length would be 2x.
Right. The length would be 2x.
Mm.
How would I find an expression for the height?
So we had to use like the formula for like the volume of a cuboid and make h the subject.
Yes, because I mean that's the only information presented to us. We have the
Okay.
volume, and so with that information we could actually make an equation in terms of h and x.
Yeah.
But they said to find an expression for h, so we'll actually have to make what the subject of the formula.
H the subject of the formula.
Yeah.
Okay. So like v is equal to 2x by x by h.
Yeah.
Okay.
Oh wait, no, this is not the question I was gonna do, but it's really, really similar.
Oh.
No,
Okay.
this is not the question I wanted to do with you guys. This is not a rate of change question.
Oh, it's not.
No, this is not. The questions are very similar though. Like extremely similar. This is not the question I wanted to do, but this is what the answer would look like, by the way, if you're curious.
Okay.
Where's that question I wanted to do with you guys? Was it like, nah, it's not that one. Where is it?
Hmm.
Where is it? Give me a second.
Okay, no problem.
Where do I have that? Paper trees. The same one. Oh, here is it. This is
Okay.
like, I mean, like, it's really similar. It's like really similar. Like diagram at least.
All right. Well, let's go, I guess.
But I would like, all you have to understand, all of these things are actually much easier than they seem on the surface.
Hmm. So they just make it like appear challenging, but it's
Well,
actually easy.
all problems on the surface seem difficult.
Hmm.
Mrs. Martha's gonna beat me.
Oh.
Yeah.
Oh, do you have to go now?
Let me just finish this real fast.
Okay.
I can't do it real fast.
Okay.
So the ship in the game has a rectangular shaped stern shown in figure 2 that takes in water at a rate of 2500 meter cube per second whenever a wrong turn is made. Okay, so what piece of information are they giving us?
Hold up.
What rate of change is that?
Ship something dt. What is that? Oh wait, dv dt.
Right. Jenna, Zachary, I'm going to fully understand why I say now this is dv/dt.
Units. Oh no.
Yeah, it is the unit itself. Like, if
Okay.
you see, Jenna, what is meter cube? Meter cube implies that you find any product of how much dimensions?
3.
3, so
Yeah, 3
that's volume.
volume.
And well, it's per second, which is with respect to time.
Yes, sir.
So they're telling us that dVdt is 2500 meter cube per second. And that's how much water it takes in whenever a wrong turn is made. So like you can imagine that this is on water, right? It's like in the sea or a pond or something. If a wrong turn is made, water is gonna do what? Like water is gonna do what?
Splash? I don't know.
Nah. Read it back.
No. Okay, the ship in the game has a rectangular shaped stern that takes in water at a rate of 2,500 meter cube per second whenever a wrong turn is made. I don't understand. What was that supposed to tell me?
Alright, so
What's a stern?
okay, it's the stern of a ship.
Okay, well, what is it? I'm confused.
Generally speaking, if you take like a wrong turn, like in my head, like it might dip and water might flow in.
Oh, so not like splash. Okay. Okay.
Let me see if I can show you guys.
Okay.
Interesting. Watch.
Oh. Okay.
Like,
So the stern is like back.
Yeah. So
Okay.
I presume like if like a wrong turn is made, like water gets in.
That's what I meant by splash. I probably didn't say that in the best way possible.
Or splash.
Yeah.
So like, long story short, if it takes a wrong turn, water starts to fill it.
Yeah.
Talk to me, guys. If water starts filling that hollow stone, what things are going to change?
The volume would increase over time.
Right? So, well,
Because more
they're telling us that the volume would change at a rate of 2,500 meter cube per second. What else would respond to that increase in water? Talk to me, guys. If water starts filling this thing up,
the depth? No.
what's another word for depth?
Height?
Height.
So the HDT.
Right? So the height would change with respect to time.
And then the volume would change with respect to height.
Yeah. The volume would change with respect to height. Because the height goes up. Because height, because volume is dependent on height.
Yeah.
Like volume, like height is in the volume formula.
Yeah. Understand.
So these are some key things over here.
Yes.
They're saying show that when a wrong turn is made, the stern is filled after 6 seconds. So we have to show that if you take a wrong turn, the stern will fill up in 6 seconds.
Okay.
And they're telling us the rate of change of the volume of water to height of the stern is given by dVdh.
Okay.
So here what? In the question, they're giving us dVdt. That is 2,500 meter cube per second. And they're giving us dVdh. Right. So I want you all to think we have dVdt and we have dVdh, and they want us to show that if you take a wrong turn, it will be filled up after 6 seconds.
Okay.
Do you have any ideas?
So we want to find the HDT?
Yeah.
Okay.
That is what you want to find. Smart boy.
Huh?
So like you're smart.
Yes. My knowledge comes from you, sir.
What? It's not too much. So Jana, if I wanted to get DHDT, how would I get that?
So DH on top and DT at the bottom, and DV so they can cancel off.
Bet. How would I get DHDV?
You have to differentiate something.
Nah,
No.
I don't want to tell you, John, but you could figure this out. Like, it's right there.
200 meters squared.
Take your
So
time.
200 multiplied by.
Take your time. No, it's not 200. Take your time.
It's like the opposite.
No, tell she could do it.
Oh,
Jenna could
sorry.
do it.
Is negative. No, you flip it.
Yes. And then we
Yeah.
got-
1 over 200.
Right. You see, look, we you had to let people figure out things like they could do it. Because what? DVDH is 200, which is the same thing as 200 over 1. So if I
Yes,
were to
sir.
flip both sides, DVDH will be 1 over 200.
Okay.
And we're going to multiply that by DVDT. What is
Which is-
DVDT?
2,500.
And what would you get?
25 over 2.
Mm-hmm. What would that simplify to?
12.5.
Okay. And what would the units be?
Meters per second.
Because height will be measured in
Meters.
and time is measured in.
Seconds.
So every time you take a wrong turn, Jenna, your height increasing by how much meters?
12.5 meters per second.
Where's like the maximum height?
75 meters.
I'm gonna leave it to you now. How would you answer the question?
12.5 divided by 75.
Think you mean to say that the other way around?
Yeah.
Yeah. But
Sorry.
yes, that's okay. So what's 75 divided by 12.5?
6.
Bam. Absolute cinema.
That seems so easy.
It does, right? I'm trying to like prepare you for like the worst case, like nothing should be able to affect you. Like you all should be unfazed.
Yes, sir.
Like after you all like do this work with me on this grind, like everything gonna become so easy. Like it's like hard maths, hard what? Nah, it's like easy.
Yeah.
So that's what I want to think about maths, because right now I still kind of think it's hard. Not for differentiation though.
Okay, well, I mean, you're only in my class for differentiation, so
Yeah.
when like we do other topics, you'll see like how easy it is.
Well, except for the tangents and stationary points, that's still kind of.
No problem.
Yeah.
We could do some lives to lock that in,
Yes, sir.
right? But yeah, hope you guys have a. I didn't wasn't too bad. I mean, it was too bad. We didn't like see that. I had some sort of discipline. you know?
Yes. Yeah.
It was only like 101, 47 minutes.
Almost 2 hours.
Yeah.
But he has to know that. I mean,
Yeah,
I'm sure Mrs. Matt Vibes watching this live right now.
I don't know.
This is not vibes.
I,
Is she?
I think she is. Isn't that her commenting with the sparkle?
Yeah.
Oh,
So
then
anytime
she
when I see
is.
somebody commenting like acting with the real Toasty, it's probably Mrs. Matt Vibes.
Oh, okay.
Yeah.
Oh, damn.
Yeah. But hope you guys have a blessed night. I will send these notes on the
You
group
too,
chat.
sir.
Yeah,
Take
you
care,
too,
guys.
sweetie. Bye.
Bye, sir.
Bye.